Electric-powered rocket engines have been the talk of the space community for a while now. It is believed to be the technology that will dominate the space industry for years to come. Just recently, China, the showstopper for 2022, announced that the CSA is all set to make a move in the electric-powered engine domain of the space industry as well. The Chinese Space Agency, which was swamped with research and launches in 2022, is expected to surpass all its launching milestones in 2023. Right at the beginning of 2023, the Chinese Space Agency established a thrilling start by making headlines for another launch event that is likely to take place very soon. Today, we are going to take you on a tour of the launch of one of the mightiest satellites in space with electric-powered rocket engines and how this launch is expected to be a huge breakthrough for the space industry. Hello, and welcome back to another video of The Door to the Universe, the channel where we keep you updated on the highlights of the space industry. These electric-powered rocket engine satellites function on the principle of packing a high-energy electric drive. As suggested by the name, these satellites are expected to change the whole perception of electrical energy-induced objects roaming in space. Although China has already launched the satellite and owns most of the credits for the launch, China could not do it alone. Major space agencies and authorities of the world have contributed to the working, implementation, and launching of the process of this technology, along with China. The question is, why would great space programs help China and let them own the major credit? Well, the answer is to gain the global benefits that come with the launch of this incredible project. The first launch of this technology is expected to pave the path for a range of new developments with fewer risk factors for space exploration. Now, let's get to the formal introduction and technicalities of this satellite. The satellite was named APSTAR 6E, weighs 1,800 kilograms, and is expected to have a lifetime of 15 years. APSTAR 6E was launched from the top edge of a massive Long March 2C rocket. The Xichang Launch Center in the Sichuan province launched the satellite, and it was the third launch by the Chinese Manned Space Agency since the start of the new year. These three fruitful launches include 2 rockets and a satellite that were designed and created by the China Aerospace Science and Technology Corporation. The APSTAR 6E is designed to offer a high-speed and advanced quality communication service to consumers in Southeast Asia. The technology operates with a total bandwidth of over 30 gigabytes and artificial intelligence techniques to eliminate or minimize the interruption from the ground control network. The official newspaper of the Ministry of Science and Technology Daily stated that the satellite will conduct the first in-orbit verification of high-power ion and Hall electric propulsion technology. The satellite is fixed over a rotation orbit over 134 degrees latitude from where it is supposed to provide a payload of 30 gigabytes payload with an impressive capacity of 26K U-band and 3K band user beams. APSTAR 6E will settle and revolve at the height of 35,786 kilometers from the equator of Earth. Although the satellite is going to spend most of 2023 to rise and reach its actual position, the geostationary orbit, it was initially launched near low Earth orbit. This technology launched with a highly functional separable propulsion system. This propulsion system is designed to power up the satellite to reach a higher orbit. After this power-up, the satellite's propulsion will go for the geostationary journey, which takes a month. Talking about the construction process of the APSTAR 6E, the satellite was developed on the class cast of 1.3-ton FH-3E platform. The satellite standards for APSTAR 6E were made from light to medium. The satellite has 2 huge panels that expand to 18.10 meters. These panels power its transponders, and the electric motor can function for nearly 15 years, through which the mission is expected to reach its destination. The DFH-3E plays a part in meeting the requirements of the low-cost geostationary communication cellulite in developing countries. The satellite will take 10 months to reach its designated geostationary position. The Orville Stage YZ-1S will embed a GTO transfer in APSTAR 6E. The insertion process will take about 10.5 hours, and from there, it is expected to take 10 months to finally reach the missionary position using its electric motor. The official statement and information release didn't state how much power this satellite can generate, but according to estimates of its propulsion system that falls in the high-power category, can create from 10 to 100 kilowatts in space. This amount of energy is produced by using an electromagnetic phenomenon called the Hall effect. The Chinese space authorities declared that 5 kilowatts of power is used by the most powerful electric propulsion system nowadays. The Apstar 6E will shed all its rocket engines in the near-Earth orbit and is expected to reside in the orbit 30,000 kilometers from the surface of the Earth. If we compare the efficiency of electric space engines that use solar energy and engines that burn fuel to power the engine, then the electric engines get the benefits of being 10 times more efficient, according to the South China Morning Post. A 5-ton communication education satellite requires to carry approximately 3 tons of rocket fuel. However, electric propulsion can simply cut it to 500 kilograms. In the Chinese Space Agency, teachers are being conducted to get a closer look at the benefits and utility of such engines, as they tend to reduce the expenses of any future launch from 25% to 50%. Solar electric propulsion means the combining of electric thrusters and solar cells to shoot a spacecraft or satellite into outer space. Not only the Chinese, but many other big authorities of space, such as the European Space Agency, the Indian Space Research Organization, the Japanese Space Agency, and NASA, the technology of Apstar 6E has been manipulated into a range of spacecraft. The SEP possesses a higher specific impulse than the ordinary chemical rocket, which means that less propellant mass is needed for the launch. This is the same technology that is expected to take humans to Mars safely in the future. The first fruitfully launched electric propulsion was developed by NASA. Later, it was used and exploited by many other space agencies, such as the Russian and American satellites. In the future, the electric thrusters will be able to impart a delta 5 of 100 kilometers per second. This kind of force is enough to shoot a spacecraft to the outer planets of the solar system. Moreover, an electric rocket with an external power source that is transmissible with laser on the photovoltaic panels has a theoretical possibility for interstellar travel more than a spacecraft. Nevertheless, electric propulsion is not safe to be launched from Earth's surface directly, as the Earth's surface is incapable of providing enough thrust for the launch. Nowadays, multiple researchers are in the process of this technology and launches to drastically increase the success rate of launches. According to a paper published in the Chinese Journal of Technology, China is working on ultra-high power electric drive with a gain of hundreds of kilowatts to power a number of massive space projects, including a solar power plant. The Chinese company completed its Tiangong space station last year, which is supposed to power many future missions, including experiments, launching, and research. One of the earlier mentioned missions includes the development of a solar power plant from space. Now it seems that the Tiangong space station centralized the Chinese space industry somehow, as it's a massive station with countless resources and the latest technologies. Nearly all future launches, experiments, and missions will circle around the Tiangong space station. The solar propulsion electric technology also plays a part in making Tiangong Station reliable enough. Since space is full of new launches and missions, let us know which you are curious about in the comment section. Don't forget to subscribe to never miss an update.